Time flies. We are at the end of the class, and we are going to have a brief review for the final exam using the reference tables. Please remember, just like on the midterm exam, it is honor locked, and you may use a clean copy of reference tables part 2. Also, there is a review, just like the midterm, that is available, optional. You don't turn it in. So without further ado, the first table refers to oceanography. You can see you have your gyras and the North Atlantic, South Atlantic, North Pacific, South Pacific, Indian Ocean gyra. And then you also have the west wind drift, or the Antarctic circumpolar current. That is the current that travels around the entire planet. Incidentally, that is why Antarctica is colder than the northern area, because the circumpolar current blocks that warm flow from equatorial waters, isolating Antarctica more than the Arctic area is isolated. So you see the gyras, you see the major currents. Again, latitude and longitude, you should know. Warm currents are on the east coast of continents, and they originate equatorially. These revolve around high pressure systems, so they are clockwise, where our low pressure systems, as you recall from our meteorology unit, are counterclockwise. So they go around high pressure systems. You can see how climate's affected. You get the warm water pumping north or south from the equator, and then the cooler water from the polar regions moving toward the equator. So these are the ocean basins and the major currents. Recall what drives ocean currents. Surface currents are driven by global winds, and they are steered by the Coriolis effect, that spinning rotation of the Earth. When we move into meteorology, you can see our 3 types of temperature: Fahrenheit, Celsius, Kelvin. Kelvins are the SI units. They are used when we talk about astronomy and for some thermodynamics. Celsius and then Fahrenheit, and you can easily move from one to the other by using that little scale. Air pressure, and recall, air pressure, really, rising pressure is low, rising air. Wind moves from high to low. That rising low pressure brings storms. The sinking air, the high pressure, brings clear weather. So a real weather maker is these pressure systems. And you can see standard pressure, 1 atmosphere, in inches of mercury, which is how it was done with mercury barometers, and millibars, which is what we use. You can also see the weather map symbols and the station models with all of the properties. You're given the air masses, and if you remember, the air masses are these large air parcels of air with similar temperature and conditions. You're giving the front symbols, so you have a lot of information from our meteorology unit at your fingertips. These matrices are the dew point, and remember the wet and dry bulb temperature. As water evaporates from the wet bulb, the temperature drops, so the drier the air, the more evaporation, the greater the difference between wet and dry bulb, and we use these to determine the dew point and the relative humidity. If you have a hard time recalling how to use these, please go back to the meteorology unit and check out the tutorial. Our planetary winds, or our global wind belts, are very important in oceanography because they steer the ocean currents, and meteorology because they move our weather systems. You can see we have the trade winds, the northeast and southeast trade winds, the prevailing westerlies, which blow most of our weather systems around North America, and then the polar easterlies, with these jet streams that are located where the 2 different winds meet. Rising air brings wet, so you have the low pressure belts are very wet, and sinking air brings dry, so the high pressure belts are very dry. The electromagnetic spectrum, as we move into astronomy, stars give off electromagnetic waves. We see that narrow band visible light, the Roy G. Biv, but there are many different wavelengths of electromagnetic radiation. The stuff we can see we call light, but the others are present nonetheless. The bottom table, the solar system data, gives you the information for each of the planets and the moon, our moon, mean distance from the sun. Remember, orbits are elliptical with the sun at one of the foci, so the distance changes from the sun. The mean is the average distance. And the period of revolution is how long it takes for it to circle or orbit the sun. That would be a year. The period of rotation at the equator would be analogous to a day, how long it takes that planet to spin once. The eccentricity is how egg-shaped that orbit is. And of course, the diameter, the mass in relation to Earth. So you can see Earth's moon has less mass than Earth, where the Jupiter is 317 times more massive than the Earth. And then the density. So that is some solar system data. The Hertzsprung-Russell diagram up above, you can, there's some stars given, and then there's the general stars given. The main sequence are your dwarf average size stars. Most, 90% or so, fall on that May sequence. And you have your blue, your white, your yellow, and your red, depending on the temperature. Then you have your supergiants, and some can be blue, very, very hot. Some can be red, very, very cool. Just depends on where they are in their age cycle. And then you have white dwarfs, which are stars that have seen their life, past their prime, and they're toward the end of that stellar cycle. Some of the major stars given, like Sirius, the largest star that is visible in the night sky, or Proxima Centauri, our nearest star, Proxima, proximity. You can see Betelgeuse. Betelgeuse is a famous movie. It's also a famous red giant in Orion's belt. And Rigel is part of Orion as well. And Deneb, actually, Betelgeuse is the armpit of Orion. Polaris is our north star, the pole star. Every star seems to go around Polaris in the northern hemisphere. But that is because of Earth's rotation. You can see the temperature of each star, the relative brightness of each star, and the color. So that is our final unit. Good luck on the exams. I'd like to thank you for participating in our Earth Science program. I hope you enjoyed it, and I hope that you have the best of luck in your future classes. Have a great day.